This next video is concerned on the identification of midpoint. Just to distinguish or just to differentiate the notations we used for distance, we are going to use this small labeling MD, which stands for midpoint. In short, number one, MDPQ means the midpoint between the points P and Q, or the midpoint of the line segment containing the boundaries of or boundaries which are points P and Q. The formula for getting the midpoint is actually um, derived from the concern of the another theorem, the midpoint between points theorem, okay? Which means that if a point, let's say point M, is a midpoint of points A and B, there definitely the measurement of line segment AM, okay, is equal to the measurement of line segment AB. Okay, this is actually what is in that theorem. Okay, if M is the midpoint of A and B, we have this, and then we actually use this later on to, and then with the segment addition postulate to derive the formula. Okay, but it should be considered that the points here, including the midpoint, are collinear. But let's not talk about that. We are going to talk about the formula already, which is actually, in this case, the midpoint is equal to the sum of the coordinates of the endpoints divided by 2. We also use the term here, the average of the coordinates of the endpoints A and B. So for number 1, the formula in getting the midpoint between points P and Q, or the midpoint of the line segment PQ, is simply add the value or the coordinates of P and Q and divide them into 2. Right? This 2 here is constant. It's always 2 because it follows the concern of midpoint. Midpoint, it's the middlemost point. It divides the line segment into 2 equal parts. That's why it's always divide over 2 here. Let's try to have it in number 1. P is given to be negative 1 and Q is actually 8. So negative 1 plus 8 all over 2. And that is actually 7 halves. Some of you might say 3.5. Which of the two is acceptable? In reality, and what we're going to follow is we are going to accept both of them. As to why, take note that 3.5 is also a real number. It's actually the equivalent value for 7 over 2. Since both of them are real numbers, and we do have the ruler postulate which that tells us that any point in a line could be in one-to-one correspondence with a real number, we are going to accept both of them. Okay, so both of them are acceptable and will consider to be a correct answer. Let's proceed to number 2. Let's have here S plus Q all over. Let's make it better. S plus Q all over 2. S is given to be negative 9 and Q is 8 all over 2. So you have here the value of negative, what do you call this one? Negative 9 plus 8 is negative 1 half, or over 2, or negative 1 half. Or you could actually say, this is a different color to differentiate. You may also say negative 0.5. So this is a midpoint of point between points 9, uh, negative 9, points S, which has the coordinate negative 9, and point Q with coordinate of 8. Look at the answer here. One of our possible answers for midpoint is a negative value. Take note that in distance, in the previous practice exercise, we do not accept negative distance because distance is always positive. However, for midpoint, it's all possible for us to get a negative real number. Why? Because midpoint is just a point between or in the middle of two different endpoints. And a point could be could be in one-to-one corresponds by any real number. And negative numbers are real numbers. Right? So we are not talking here about distance anymore. We are talking about the midpoint. So negative values will be acceptable. Let's proceed to number three, R and P. This actually, we have R plus P all over 2. R is given to be with 4 plus P, which is negative 1. So all over 2. 4 plus negative 1 is 3. You have here over 2 or 1.5. Both of them are acceptable. You might notice that all of our answers here in your fractional or in decimal form is not all the time. Okay, don't forget that we have plenty of examples of real numbers as what we have discussed in in the first grading. Just like in number four. Number four, you have here SP, S plus P all over 2. So S is negative 9, P is negative 1 all over 2. So negative 9 plus negative 1 is negative 10 all over 2, which is actually equal to negative 5. If fractions or values with decimal notations are possible, then definitely integral values, just like negative 5, is also possible. Okay? And again, emphasize here, negative values are acceptable. No more equivalent for this or decimal notation because that stands as this. And finally, for number 5, you have Q, 8. Let's write first the Q to be consistent. We have R all over 2. Q is 8 plus R, which is 4 all over 2. 8 plus 4 is 12 over 2, which would actually be equal to 6. So 6 is the midpoint between points Q and R, or the midpoint of the line segment bounded by the points Q and R. So this is how we solve for the midpoint between points. Please use this as part of your review and prepare for an assessment later. Goodbye, everyone.